Hello everyone and welcome back. Question 17 for the end of term exam has two questions. So this file has two similar questions. So let's work on both of them. Question 1 says, sculpture uses a constant volume. This is a key word in this question, constant volume. Right? Of modeling clay to form a cylinder with a large height and a relatively small radius. The clay is modeled in such a way that the height of the clay increases and the radius decreases, but it retains its cylindrical shape. At a specific time, at t equals c, the height is 8, the radius is 3, and the radius is decreasing at a rate of ½ inch per minute. So there are three parts to answer. So we have a cylinder that has a height as well as a radius, and it has a volume, right? Now, dV over dt is equal to 0 because the volume is constant, so it's not changing. The radius is decreasing, so we have a change of radius over time, but it is negative. It's going to be negative. Later on, we will find out that it's negative, okay? The height is changing, it's increasing, so there is a change. So there is dH over dt. So this is the cylindrical shape. Now it says at a specific moment at t equals c, the radius is equal to 3, the height equals 8, and the radius is decreasing, so dr over dt is equal to -1/2, -½ So those numbers we will plug them in after differentiation, after the derivative. Okay, now in part A it says at that moment, at t equals c, at what rate is the height? Sorry, I'm reading part B. At time t equals c, at what rate is the area of the circular cross section? So circular cross section, and it's an area. So the area has a formula given pi r squared, and because the radius is changing, the area is changing as well. So you will differentiate this formula with respect to t. So this is going to be dA over dt equals 2 pi. Pi is just a number, leave it in front. We will put the 2 in front, decrease the power by 1, and differentiate the inner, which is r of t. So dr over dt. It's the chain rule. Okay, now the question is saying at t equals c, at what rate is the area of the circular cross section of the clay decreasing? So dA over dt is equal to 2 pi times r, which is 3 at that moment, and dr over dt is equal to -½ So the area is decreasing at a rate of -3 pi, and it says indicate the units. The units will be square inches per minute. square inches or inches square per minute. This is part A. So part B says at T equals C, at what rate is the height of the clay increasing? dH over, here it says at what rate is the height of the clay increasing, يعني dH over dt. Find dH over dt. So let's work on part B here. The volume of the cylinder, this formula, it relates the radius with the height. So it is pi r squared h. So let's name this one first, because r is changing, it's a function of time. H is a function of time as well. So we will use the product rule to differentiate the volume with respect to t. So dV over dt is equal to, differentiate the first, 2 pi r dr over dt, leave the second, which is h, plus, leave the first, pi r squared, differentiate the second, the derivative of h is dh over dt. Now we will plug in the numbers. The volume isn't changing, so this is 0. This is 2 times pi. At t equals c, the radius is equal to 3, and it is decreasing at a rate of half, times the height. The height is equal to 8, plus pi times 3 squared times dh over dt. I think that we are looking for. So this is 0 equals negative 24 pi plus 9 pi dh over dt. Now get this thing to the other side, it becomes 24 pi equals 9 pi dh over dt, and then you will divide by 9 pi, divide by 9 pi, okay. So dh over dt will equal to, pi goes away with pi, divide this by 3, this by 3, this is going to be 8 over 3. And because it's height, the unit is inches per minute. This is part B. In part C, write an expression for the rate of change of the radius with respect to the height. So this is really important. Write an expression for the rate of change of the radius with respect to the height. That means dr over dh. We will differentiate with respect to h, not with respect to t. So this is part C again. The volume equals pi r squared h. Let's differentiate this formula with respect to the height. With respect to the height. So dv over dh equals, again, this is first and this is second. So the first term will be 2 pi r dr over dh. Okay, so this is the first, we leave the second, plus pi r squared. We leave the first, we differentiate the second. Now when you differentiate the height with respect to the height, it is just 1. So as we differentiate x with respect to x, what's the derivative of x? It's 1. So let's isolate dr over dh. We said that the volume is constant, so it's not changing, so it's 0. 0 equals 2 pi r dr over dh plus pi r squared. So minus pi r squared on both sides. So negative pi r squared equals 2 pi r dr over dh. Divide by 2 pi r by 2 pi r. So this is going to be dr over dh. The change of radius with respect to height is, if we just cancel the pi with pi, this radius with this power, it's going to be negative r over negative r. We forgot something over here. Let's just put the h here. We forgot the h, right? We forgot this h. So you will divide by h, you will divide by h. Sorry for that. So this is going to be negative r over 2h. That is dr over dh. That's it for question 17. Question 1. All the best.